Hello, welcome to another video. It's been a while, but then I can hardly get a certificate for YouTubing if I don't actually YouTube. So I've got the water, paper, and the weight, and that's going to make a stand for me to do this. So you hopefully see my paper. I just tilt that up a little bit. Maybe, oh no, rotate it down. Don't worry, I'll edit that out if I ever get some editing software. I'll just tilt it up a little bit. There we go. Now we've got the perfect box. I'm still here, but you won't see me. So I wanted to talk a little bit today about relativity. And so what we're going to have is a spaceship. It's always a spaceship, and it's always Sally. So let's draw the spaceship. Nice aerodynamic spaceship, although that doesn't matter because there's no air in space. And Sally is sat there in the spaceship, and it's quite a long spaceship. In fact, it's 6 times 10 to the 8 meters long. So this half length here is 3 times 10 to the 8 meters. We can see that, okay. And of course, the spaceship goes back here, maybe like this. Store all the fuel, I imagine. And this half here is also 3 times 10 to the 8 meters long. So total length of the spaceship is 6 times 10 to the 8 meters. And Sally actually. Sally is moving to the right at a velocity that is a significant fraction of the speed of light. So maybe 80-90% of the speed of light, okay? Then, for some reason, in relativity, it's always Sally and Sam. Sam is stood on some platform or some planet, and he's just watching Sally whiz by. So Sam is going to be what we call stationary, the stationary observer. Of course, you will know that no one is actually truly stationary. It is all relative, no pun intended. So what's going to happen? Well, at midnight, that's midnight, that's 12 o'clock, 0 minutes and 0 seconds. Sam observes a lightning strike, excuse me, at the front of Sally's spaceship. And how does Sam know that the lightning struck the front of Sally's spaceship at exactly midnight? Well, I'll draw it this way so you can actually see the path the light's traveling. The light travels from the front of Sally's spaceship and gets to Sam at, believe it or not, 12 midnight, 0 minutes and 1 second. That there is 1 second, because light, as you probably know, the speed of light, c, is 3 times 10 to the 8 meters per second. And so it's going to take light 1 second to travel from the front of Sally's spaceship to the middle. Don't worry about that distance there. We're going to say that in this y direction, the vertical direction, that there is negligible distance between Sam and Sally. So we're comfortable saying that approximately the light travels 3 times 10 to the 8 and arrives at Sam at 1 second after midnight. And Sam sees that the light comes from the front of Sally's spaceship, and he knows that Sally's spaceship is 6 times 10 to the 8 meters long, and so the front end of the spaceship is 3 times 10 to the 8 meters away. He says, well, if the light is just arriving to me now at 1 second after midnight, and the speed of light is 3 times 10 to the 8 meters per second, and the front of Sally's spaceship is 3 times 10 to the 8 meters away, then that lightning strike must have occurred at exactly midnight, okay? I didn't say, what I should have said is that at midnight, Sally and Sam happened to be in the same position. I didn't draw it very well there. I was supposed to draw Sam and Sally in the same position here along the x-axis right there, if you like it, x equals 0. So you just need to be aware of that. I didn't draw it brilliantly. Okay, coincidentally, a lightning strike strikes the back of Sally's spaceship, and according to Sam, here comes the light from the back of the spaceship, and according to Sam, the light arrives to him again at midnight. Well, not midnight, 1 second past midnight. Remember, that's 1 second past midnight. Again, Sam knows that the back of Sally's spaceship is 3 times 10 to the 8 meters away. He measures the speed of light to be 3 times 10 to the 8 meters per second. The light arrives 1 second after midnight. He knows that it must have taken 1 second to travel that distance, and so Sam concludes that the lightning strikes the back of Sally's spaceship at midnight. Nothing particularly problematic there, but Sally is moving at some significant fraction of the speed of light. So what does Sam see Sally do? Well, when the light leaves the lightning strike at the front of Sally's spaceship, of course, Sally, according to Sam, is moving to the right? And so maybe by the time, I'm going to draw in a dashed line to show this is where she would be by the time the light gets to her. By the time that the light gets to Sally, Sam says, well, she's moved forward a little bit. And so Sally will say that the light arrives to her. She will look at her watch and she will say, I'll draw Sally's time maybe just here. She will say, oh, the light arrived to me at midnight. Remember, this is minutes here. This is seconds, and then maybe 0.7. That's 0.7 seconds after midnight. Okay, so again, there's nothing particularly unusual going on here yet so far. I might just see if I can tilt this just a little bit so you can see nice and clearly. So there's nothing particularly wrong there. And Sam and Sally, they've both got light speed measuring devices. Let's maybe draw it like that. Yeah, they've got light speed measuring devices. All they've got to do is point their light speed measuring device at the light and it will tell them the speed of light. Now, there's two possibilities for why Sally sees the light arriving to her at 0.7 seconds after midnight, whereas Sam sees the light arriving to him from the lightning strike from the front of the spaceship at 1 second after midnight. The first possibility is, according to our kind of everyday understanding, is that Sally is moving forward relative to the light. And so if she used her light speed detecting machine here, she would, in this theory, measure the speed of light to be greater than 3 times 10 to the 8, because the light's moving towards her and she's moving towards the light. It's like if your buddy was cycling to you at 10 meters per second and you were cycling towards your buddy head on at 5 meters per second, it would be like your buddy was riding towards you at 15 meters per second. So Sally uses her light speed measuring device, and lo and behold, she measures the speed of light from this lightning strike to be 3 times 10 to the 8 meters per second. Oh dear. That is perhaps not what we would have expected, but it is the first postulate of special relativity, that the speed of light is constant in all inertial reference frames for all observers. So now let's place ourselves in the shoes of Sally. She is sat there in the spaceship. She knows, or she sees light from a lightning strike from the front of her spaceship. She knows that the front of her spaceship is 3 times 10 to the 8 meters away. She measures that the speed of light from this lightning strike is 3 times 10 to the 8 meters per second. So she says, well, at this speed, the speed of light is 3 times 10 to the 8 meters per second, and the origin of the light is 3 times 10 to the 8 meters away. It must have taken this light 1 second to get to me. And so she concludes that the lightning strike at the front of the train trying to get this right, that's 59 minutes and 59 seconds, point 3, right. 1 second before the light arrived to her. And this is one of the interesting results of the fact, the physical fact that the speed of light is a constant for all observers. Sam says that the lightning struck the front of the spaceship at exactly midnight, and Sally says, no, according to me, that the lightning struck the front of the train at 0.3 seconds, sorry, 11:59 minutes, 59 seconds, 0.3, right, 59.3 seconds. Okay, so this seems strange. What does Sally think about Sam seeing the light? Stating that the lightning strike occurred at midnight. Well, according to Sally, she is stationary. Everybody is stationary with respect to themselves. That's another kind of idea that you need to become familiar with. So Sally just thinks, I'm stationary in my spaceship, and Sam is whizzing to the left at some significant fraction of the speed of light. And she says the reason that Sam, receives the light from the lightning strike at 1 second after the midnight rather than 0.7 seconds after midnight is that in the time that the light travels from the lightning strike to Sam, he has moved away. He has moved away from the lightning strike. We can also do the same analysis for the back of the train. And so the lightning strike from the back of the train, as it's traveling towards Sally, well, according to Sam, Sally is moving away from that light. And so maybe the light from the back of the train arrives to, just trying to get this right, maybe it arrives to Sally at 12 midnight, 0 minutes and 1.3 seconds. Remember, for Sam it was 1 second after midnight. Maybe for Sally it's 1.3 seconds after midnight. Now Sally again uses her speed of light measuring device, and she measures the speed of light to be 3 times 10 to the 8, 3 times 10 to the 8, which all observers will measure the speed of light to be. Sally also knows that the lightning strike came from the back of her spaceship, which is 3 times 10 to the 8 meters away. And so she concludes that it must have taken the light 1 second to have traveled the distance from the back of my spaceship to me. And so she will say that the lightning strike, I'm going to try and get this right. So that's 12 midnight, 0 minutes, 0 seconds, and 0.3. So 0.3 seconds after midnight, she will say that the lightning strike at the back of the plane, at the back of the ship, occurred at 0.3 seconds after midnight. And so, to summarize, we now, in our theory of special relativity, need to forego this notion of simultaneity, of two things. If I say, or if Sam says, that the lightning strike at the front and back of the plane happened at the same time, before the theory of special relativity, we would have said that all observers would say that the lightning strike at the front and the back of the spaceship happened at the same time. But special relativity teaches us that simultaneity is really a property of what we call a frame of reference that is unique to Sam's frame of reference. And according to Sally's perspective, her frame of reference, the lightning strikes are not simultaneous. They do not happen at the same time. And furthermore, both Sam and Sally are correct. There is no, it's not like we can say, oh, Sam is correct and Sally is just mistaken. This is a fundamental property of the universe. So if you understand that, well done to you, because that is one of the more tough concepts in the IB physics course. And that just goes to show that you can definitely study IB physics. So I look forward to seeing you on the course. I would just, well, that weight is a bit on the heavy side. So yeah, I think I am here. Is that upside down? Maybe that's all right. So yeah, well done, and I'll see you next time.